Welcome to section 6.1, all about trigonomic functions of acute angles. So most of this will be review. If there's anything I teach a certain way and you preferred a different way, go for it. I just show one way, but there are definitely multiple ways to solve this. So first thing I want to talk about is the names of functions. So as you can see here, there is a lot of functions: cosine, sine, tangent, secant, cosecant, and cotangent. They have their abbreviations that you will see when we're writing it out with mathematical statements, so be familiar with those. Now, looking at this picture I have my angle of focus, so my theta right here, and based off of that angle, I need to label the side that is opposite, adjacent, and then of course the hypotenuse. So looking at this angle, the side opposite is obviously opposite of the angle, so I'm going to put a big O. O for opposite. The side adjacent to it is the side that touches the angle but is not the hypotenuse. So this is the adjacent side. Then the hypotenuse is the one always across from the 90-degree angle, and you can label that H. Doing so allows you then to apply the trig function. For example, cosine is the adjacent over the hypotenuse. So in the cosine line, I'm going to write adjacent, not with a highlighter, adjacent over hypotenuse. That is the ratio that goes with cosine. Sine is opposite over hypotenuse, so O over H. Tangent is O over A, opposite over adjacent. And then we have our three: secant, cosecant, cotangent. Those are what we call the reciprocal, my dears. So reciprocal of one of the three previous functions. So secant is actually the reciprocal, or 1 over cosine. So all I need to do is take the cosine ratio and flip it. So cosine is normally A over H. Now it's going to be H over A. Cosecant is 1 over sine. So you take the sine and reciprocal it. I don't know if that's a term, but flip the numerator and denominator. Then you can guess cotangent is 1 over tangent. So that would instead be A over H. A over O. This is a lot, right? But we all learned a fabulous way to remember this. Hopefully this sounds familiar. So, ka, toa, yeah. Right, this will be our saving grace to help us remember all of these functions. The S in so reminds us of sine. Sine is O over H, opposite over hypotenuse. The C stands for cosine. Cosine is adjacent over hypotenuse, hence the CAH. TOA is our tangent, and tangent is opposite over adjacent. So let's use that as we move forward, and then be familiar with the secant, cosecant, cotangent as just flipping the previous function. So looking at a couple examples, finding the trig ratios. Here's an example picture. Notice this is my angle of focus right here. So everything is based off of that theta. And you can tell because I write sine theta, cosine theta, tangent theta. I am a huge advisor of labeling opposite, adjacent, hypotenuse. So the opposite side is here. Adjacent is the side touching. And as always, across from the 90 is the hypotenuse. Sine, using either SOHCAHTOA or if you already know, sine is O over H. So I'm like O over H. Looking at my picture, the side length associated with O is really 50. H is the hypotenuse, which is really 30. I'm always going to simplify, so I get 5/13. Cosine, looking at SOHCAHTOA, is A over H. The side corresponding to A in my picture is 120. My hypotenuse is still 130. I simplify, 12 over 13. Tangent is O over A. My opposite side is 50. My adjacent side is 120. And you simplify. Not too bad, right? Now let's do cosecant. Cosecant is really 1 over sine. So it's going to be the hypotenuse over the opposite side. Looking at our picture, the hypotenuse is 130. The opposite is 50. So that is 13 over 5. Secant is 1 over cosine. Cosine flipped over. It's going to be the hypotenuse over adjacent. 130 over 120. 13 over 12. And the last one, if you're noticing the pattern, great. If not yet, that's okay. Adjacent over opposite. 120 over 50 equals 12 over 5. Now, yes, you can go through and show all these steps over and over. Once you feel comfortable, please feel free to leave out the O, A, and H's. And you also can notice something really cool. The sine reciprocal is cosecant. Notice the answers are just the reciprocal, of course, right? Because it's the flipping of the numerator and denominator. So if you know sine, voila, you know cosecant as well. Use that if you would like. Otherwise, still just solving with SOHCAHTOA is a fabulous option. Next, we're going to calculate sine and cosine. The biggest thing we have to remember in this case is we're finding exact answers. Exact means with a square root or a cube root or some kind of root. We try to stay away from those decimals. That is what's called approximate. So with exact, we're doing sine. Sine is O over H. I'm going to go to my picture. Our angle of focus now is beta. So right here, this angle is called beta. We go opposite, adjacent, across from the 90 is hypotenuse. So when I go to find sine of beta, it's 3 over an unknown length. Oh, poodles. Well, we can find that unknown length. It's a right triangle, which gives us a little idea of Pythagorean theorem. Yes, the fun stuff is back. So let's do a quick Pythagorean theorem, which means you take your side squared plus your other side squared, or your legs, and it's going to equal your hypotenuse squared. So I'll even call it h squared. That's your Pythagorean theorem. A squared plus b squared equals c squared. So when you solve the left side, you'll get 10 square root. The hypotenuse is actually the length root 10. It is a positive length, so please do not include the negative. It doesn't make sense to have a negative side length. So h right here is root 10. Now we can fill in our sine ratio. Okay. So beta, the side opposite is 3 over hypotenuse is root 10. Doesn't look too bad, right? However, you may not leave a square root in the denominator. No, can't do it. So what you're going to do, and I'm actually going to move it down a little bit so we can look at it as together. You have to multiply by root 10 over root 10. Okay, multiplying by what's called the conjugate. The reason why I picked root 10 over root 10 is because in the denominator, well, numerator, I get 3 root 10. In the denominator, root 10 times root 10 is root 100. Think about it. What's the square root of 100? 10. So there you go. This is how you can leave your answer because there's no square root in the bottom. I'll actually move it a little bit more out of the way. This is what we have to do. It's called rationalize the denominator. Okay, you have to do this. I will not allow you to keep a square root in the denominator. Let's try now the cosine of beta. Same ideas, but now we're doing cosine. Cosine is adjacent over hypotenuse. The adjacent is 1, hypotenuse is root 10. Again, you may not leave your answer like this. Multiply by that denominator in the numerator and denominator. So then you can simplify. You will get root 10 on top. Denominator is just 10. This is the answer you need. Do not leave a square root. Again, rationalize that denominator so there's no square roots in the bottom. Almost done. You guys are doing great. Next is called our special right triangles. We have a 30, 60, 90, and 45, 45, 90. Many ways to learn this as well. If you like the way I teach it, great. If you want to do it your way, by all means, go for it. So the way I do it is I make a little table, 30, 60, 90. I know the proper sides would be L, L root 3, 2L. And then I can use my picture to solve through. This case, it's written out very nice for you. It's giving you that across from the 30 is just X or L. Across from the 60 is X root 3 or L root 3. And across from the 90 is 2X or 2L. So I'm just going to simplify these so that we have them in a set spot that you can now use forever and ever. You won't have to go back and actually prove these anymore. We can just use this fact and call it a day. So notice all of these are sine 30, cosine 30, tangent 30. So this is my angle of focus right here. Here's my opposite, my adjacent, and my hypotenuse because we're focusing on theta. Sorry, not theta, because we're focusing on 30. So when I label here, my opposite side is x over hypotenuse is 2x, and you can see that simplifies to 1/2. So from now on, if I ask you what's the sine of 30, you should be whipping out your answer of 1/2. Cosine is the adjacent over the hypotenuse. Again, those x's can cancel. So cosine of 30 is root 3 over 2. That is known now. Tangent of 30 is opposite over adjacent. So x over x root 3. Oh, but you realize there's a square root in the bottom. And you're like, Mrs. Frerick said we can't have a square root. So you have to rationalize that denominator. Multiply by that square root. Oops. So then you'll get x root 3 on top over 3x on the bottom. Because root 3 times root 3 is root 9. Square root of 9 is 3. Love the bells, right? Cancel out those x's. Tangent of 30 is root 3 over 3. That is now known. Use it as you move on with your life. Same thing now for the 45, 45, 90. It has a very nice pattern to it. It will be L, L, L root 2. Or X, X, X root 2. Just what side is across from that angle. So looking at our picture, notice both of these angles are going to be 45 degrees. Right? They have to be. If it's a right triangle that adds up to 180 degrees, it's going to be 45. So it doesn't matter which angle you're really looking at. If I look at sine, let's just say, I'll erase that for now so we don't get confused. But I'm going to call this one the opposite, the adjacent, and the hypotenuse. When I do sine, it would be x over x root 2, but you can't leave that. Square root of 2 over square root of 2 to get rid of that denominator. So you have x root 2 over 2x. Make sure you simplify. That is the sine of 45 degrees. Cosine is going to be adjacent over hypotenuse. Hopefully you realize it's the same based on the fact that both angles are going to be 45, that it should make sense. Here you multiply across, what cancels out? Root 2 over 2. So if I ask, what is the cosine of 45? You'll be loud and proud and say root 2 over 2. Tangent's our last one, which is opposite over adjacent, which just simplifies to 1. If you need to write these out at the beginning of every homework assignment, go for it. If you're starting to get those in your noggin and they make sense, even better. The last part of your assignment today for this video is verifying that an equation is true. So what I need you guys to do is when you solve this, get all the way to the bottom to show left side equals right side, and then you put a little check mark. So let's look at what this is. I'm saying 1 plus this square right there, my dears, can be moved to the outside. It's a very cool fact. Same on this right side. And I look, tangent of 45, I actually know that. Tangent of 45 is 1. So let's just simplify that. 1 squared is 1, so 1 plus 1 is 2. I have my left side equaling 2. I now need to go through and show that the right side also equals 2. Let's think of what we know. Secant is really 1 over cosine of 45 degrees. Do I know cosine of 45 degrees? Yes, I do. Right up here, it's root 2 over 2. So it's 1 over root 2 over 2. And you're instantly like, this is messy. And you should, in your head, say, I can't leave a fraction in a fraction. So this really would be 2 over root 2 squared. You know your exponent rules that both the numerator and denominator are raised to that second power. So it becomes 4 over root 2 squared is just 2. And look at that. 2 equals 2. Put a nice check mark, maybe even a smiley face. You showed that the equation is true. The left side equals the right using all your trig knowledge. If you have any questions or feel like this stuff is brand new to you, please make sure you're asking questions during class. Schedule a time to meet with me because this stuff, it's pretty fun. Have a great day, everyone.